In section 9.6, we discuss Le Chatelier's principle. So, Le Chatelier's principle states that when a change is made to a chemical system at equilibrium, the system will spontaneously return to the equilibrium position. And this was first put forward by a guy called Henry Louis Le Chatelier in the 1900s. And you might have guessed, because he wears a beret, that Henry Louis Le Chatelier was a Frenchman. So, the famous donkey cart picture, where we have this picture of a donkey with his legs in the air, takes on new meaning when we think in terms of equilibrium. So, this donkey's not where we want it to be. How can we get the donkey to get his feet back on the ground? Well, when you think about it, there are really two ways of doing it, isn't there? We could put a weight on poor donkey's back here and weigh him down. Or alternatively, we could take a few packages off the back and reduce his burden, and then his feet would come to the ground. So what we're really saying is there's always two ways to move around the balance point. So thinking about a reaction at chemical equilibrium, if I wanted this reaction to make more products, well, what I can do is increase the concentration of reactants, and according to Le Chatelier's principle, because now I have too many reactants to be at equilibrium, it will turn some of those reactants into products. Similarly, I could take away some of the products, and according to Le Chatelier's principle, the system will move to offset the change that I make, and so it will shift to the right to replace the products that I have removed. Now, if I want my equilibrium to shift to the left, I could take away some of the reactants, and according to Le Chatelier's principle, the system will move to the left to replace those reactants. Alternatively, I can increase the concentration of my products, and according to Le Chatelier's principle, the system will want to consume those products, turning them into reactants, and shift to the left to offset that change. Temperature can also result in a change in the position of equilibrium. In an exothermic process, heat is a product. As a result, increasing temperature or adding heat shifts the reactions towards the reactants. Why? Well, because we're going to add some heat, and according to Le Chatelier's principle, the system will respond to offset the change that we have made, and will want to consume that heat by shifting to the left. Of course, if we do the opposite and lower the temperature, we would be removing heat, and the system would move to the right in order to replace the heat that we are removing. In an endothermic process, heat is a reactant. So in this case, if we add heat, if we increase the temperature, well, then the system will move to the right in order to replace, in order to remove the heat that we have added. And of course, the opposite is true. If we lower the temperature, we're removing heat, and the system will spontaneously move to the left to replace the heat that we have removed. So basically, Le Chatelier's principle is saying, whatever change we make to the system will move to oppose that change or undo it. For a reaction involving gases, changing the pressure will also shift the equilibrium. So if we stress a system by increasing the pressure, the system will respond by consuming gas, reducing the amount of gas that is present. Similarly, if we stress a system by decreasing the pressure, the system will respond by making more gas in order to offset the change that we made. So this example asks, how does increasing the pressure affect the following reaction? And what we want to take note of is the number of moles of gas on either side of the arrow. So we can see there are 2 moles of gas in the reactants and only 1 in the products. So if the system moves to the left, because we're making gas, the pressure will go up, but if the system moves to the right, we're consuming gas and the pressure will go down. So seeing as I increased the pressure, the system will move to the right to reduce the amount of gas that is present. And that concludes the video for section 9.6 on Le Chatelier's principle.